Today's lesson is on factoring quadratics. If you remember from our previous lesson on multiplying binomials, after we go through multiplying the binomial, we will then write our answer as a sum. Factoring quadratics is working backwards from having a sum to creating the multiplication problem. We're going to go ahead today and look at two types. Types that have an assumed 1 in front of the x squared term, and types that have a number greater than 1 in front of the x squared term. First, we're going to go ahead and take a look at the problem x squared minus 12x plus 36. My goal is to find the factors that, when multiplied, will give me this as an answer. There are two strategies that I can use to make that happen. The first way is through a diamond problem, which we'll explore right now. Thinking back to when we previously learned diamond problems in this course, we're going ahead and looking at numbers that, when they multiply, give us a certain number, and when we add, give us the other. So we're going to go ahead and set it up, remembering that our product goes on top and our sum goes on the bottom. Thinking back to multiplying binomials, we get this last term by multiplying the last two numbers in each parenthesis. So because multiplication answer is product, 36 goes in the top spot. Now if you remember back, this middle term when we multiplied binomial came from adding two terms together. Therefore it's our sum, and the negative 12 goes on the bottom. Remember, you need to include the signs with your numbers. So now I'm looking at factors of 36 that add together to be a negative 12. So first I'm going to list the factors of 36. I have 36 and 1, 6 and 6, 3 and 12, 9 and 4. So now I'm going to look at which one of those, when I add them together, would give me a negative 12. However, if my answer is negative here, and my product is a positive, I need to remember that this product had to have occurred by two negatives being multiplied together, and that's why I have the negative in the sum. So my factors now will all turn negative. Negative 36 plus positive 1 equals negative 37. So that can't be my answer. Negative 6 plus negative 6 equals negative 12. So that could be my answer, but I'm going to check the other ones just to make sure. Negative 3 plus negative 12 gives me negative 15, so that can't be it. And negative 9 plus negative 4 gives me negative 13, and that's not it either. So my two factors are going to be negative 6 and negative 6. To write this now as a product, I need to remember how I got the x squared. Well, x times x gives me x squared. So one of my parentheses is going to have an x minus 6. And the other parenthesis, again, is going to be x minus 6. And that is our answer for how we would factor the problem x squared minus 12x plus 36. The next type of problem that we can use is a generic rectangle. When using a generic rectangle, again, I'm going to work backwards. I'm looking for how I can find the sum based upon what I have so far. Now I'm looking for what I can find that makes the sum. Therefore, I need to find the multiplication problem that existed first. In order to do that, I have 1, 2, 3 terms. Well, I know when I fill in a generic rectangle, I'm going to have 4 terms. So I'm going to go ahead and make 4 boxes. Now I know that when I previously multiplied binomials doing a generic rectangle, my squared term always went right here. So I'm going to put x squared up here. And thinking back to FOIL, even, we will always get the x squared by multiplying the first term. This last box on the bottom right would represent the last, which comes together by multiplying. So therefore, I'm going to put the 36 in the bottom box. Now I can't fill in these two, because I need to get these two by adding. So over here, I'm just going to make a little note that I need to get a negative 12x. Now again, I'm going to go and revisit my factors of 36 that are over here, that when I add, give me a negative 12x. I know that x times x gives me x squared. So I'm going to put my 2x's on the outside. Then, from what I did before, I'm going to go ahead and use the factor of negative 6 and negative 6. X times negative 6 is negative 6x. And x times negative 6 is negative 6x. When I add these two together, I get negative 12x. Therefore, my product came from 6 minus x and 6 minus x. The following problem I want to look at is whenever there is a number in front of the x squared. So we're going to take a look at the problem 2x squared plus 15x plus 18. As a class, we determined that the easiest way to do this form of problem is through a generic rectangle, because we found out that when we used the diamond problem, we had to go back and complete a generic rectangle after that diamond problem was finished. So we're going to go ahead and use the generic rectangle. I'm going to go ahead and fill in what I know already, okay, which would be the two terms that come from multiplication, the 2x squared and the 18. Now I'm looking for these two boxes to add to be a positive 15x, so I'm going to go ahead and write that over here. Now when you complete this type of generic rectangle, there is an amount of guessing that has to go on. I know that x times 2x would give me 2x squared, so I'm going to write x there and 2x here. Now I'm looking for terms that give me 18. Okay, so I'm going to think of my factors of 18. I have 18, 1, 9, 2, 6, and 3. So while looking at these, I'm going to say, okay, well if I need it to add to be 15, it's definitely not going to be 18 and 1. 18 plus 1 gives me 19, and that's already too much. So now I'm looking at 9 or 2, and 6 or 3. Doing a problem like this is where it comes handy having a pencil, because you're going to need to make sure that you're guessing and then that you are checking. Now that we all have the problem written down, we're going to go ahead and try these different factors. First, I'm going to try positive 9 and positive 2. 2x times 9 gives me 18x. That doesn't look like it's going to add up to be 15x. So I'm going to stop here and retry. I'm going to erase what I previously had, and I'm going to try changing them. I'm going to try to put the 2 here and the 9 here this time. 2x times 2 is 4x, and x times 9 is 9x. Well, 9x plus 4x does not give me 15x. So 9 and 2 would not be the answer. So again, I'm going to go back and try another term. I'm going to try 6 and 3 this time. Knowing before that my greater number could not be multiplied by the 2, I'm going to put the positive 3 up here and the positive 6 down here. 2 times x times the 3 gives me 6x. And x times 6 gives me 6x. Well, 6x plus 6x does not give me 12x. So I'm going to try and arrange this one more time. I'm going to try and put my positive 6 up here and my positive 3 down here. 2x times 6 is 12x. And x times 3 is 3x. When I add 12x and 3x together, I get 15x. Therefore, my two products are 2x plus 3 and x plus 6. Remember that whenever you're factoring binomials or factoring quadratics, you're looking to find the inverse, which is what did I multiply together to get this problem. You can do so by using a diamond problem or a generic rectangle. Make sure that whenever you're doing a problem with a number in front of the x squared, that we determine the best way is to do a generic rectangle. However, you may choose whichever way best suits you.